Okay. Welcome everybody. I don't think we've had a CSOC working group for a few months, so it's nice to see everybody again. Um, we'll go around the room and ask for updates, but I think this will be a cool meeting that hopefully will be of interest to a bunch of folks. We're going to talk about some ways to save money in running a Gen 3, which I think everybody will be interested in learning about, and hopefully folks can contribute their own ideas too. Um, But typically we go around, and this will be good because yeah, we haven't heard from everybody for a while. So we'll just go around based on the sort of probably random order that people appear on my list of participants. And that falls to Luca first. Luca, do you have any updates for the work you guys are
Uh,
doing Gen 3?
nothing major beside that Paul has been working with Jawad to integrate some of shift deployment changes for Gen 3, but that aside, no major updates.
Oh, right. Yes, they are working on that. I have been talking to Jawad on that, and we'll give you an update on that soon, I think. Cool. Going down the list, Gordon, do you have any updates from your group?
Not much, but we'll be onboarding a new Gen 3 just after the Easter break.
Exciting.
Yeah.
Does that mean like starting like production support, or what does that mean turning on a new Gen
And
3?
no, so that basically just a new project that we got to
Oh,
study. Yeah.
nice.
Yeah.
Anything more you can say about that now, or
No.
okay.
Uh,
Okay. No problem. Oh, that's good news though. Anything
yeah,
else?
that's all.
Okay. And Carvin, for New Zealand, do you have any updates?
Uh, no, I have a plan to try to use that uh CSOC, okay, that admin,
Ah,
but I haven't have no time recently, but I will do that later. Yeah. Mm.
okay, great. Yeah, I think we'd love to get some feedback when people really kind of get their hands dirty using it.
Yeah, that'd be really, really cool.
Did I miss any groups that are here? Um, Alan Walsh from Indiana University isn't here, but I'll give an update for him, which is very presumptuous of me. I was able to go down and visit Indiana this week and meet with the group, the RDAC portal group, and um, got to learn a lot about their project and their deployment. And it's not a real update here, but they continue to add new features, and it's a nice project. So it was great to meet everybody there.
Oh, I have one question. Last week I used the Trivy operator to scan the images of the Gen3 microservices, all the images in the Gen3 cluster. And the Trivy report many vulnerabilities. And I then have a look at the uh, uh, from the query IO, that's where the image is stored. And that, okay, in that website, it also have a secure scanning for all the images. Uh, and yeah, but for Trivy, I think it's reports many upstream OS vulnerabilities. That's not runtime. Okay, that's not related to. Well, we can mark it and bypass it, I think. Yeah, and there is one image, the Spark. Yeah, the Spark image which used in the Gen3 Spark, yeah, image which used in the ETL job, I think. And there are 73 critical vulnerabilities. Uh, uh, and I don't know how we will deal with it, handle it or treat it. Yeah.
Um, that's a good question. I don't know, Jawad, do you have any thoughts on that? I know that security team isn't on here to meant to respond, but you may have some thoughts.
I'm not sure. I haven't looked into it. I know security team has their own tools that scan our images as well. Um, yeah, I'm not really sure just exactly what the Gen 3 Spark image and yeah, I'm not sure.
Um,
Yeah.
Carvin, can you send me the output of that and I can just pass that along to the security team and they can talk about it or look it over.
Okay, I will send the link soon.
The link or how whatever is convenient, like a Word doc or a Google Doc, something.
Yeah, because in that query IO, we can see the uh, vulnerabilities. It reported. Okay, in our locally, the Trivy operator also report more vulnerabilities. Yeah, I will send you the link and the report. Okay, later. Let me
Okay.
give me some time. Yeah.
Sure. Yeah, no problem. Just
Mm,
yeah, send it along though.
mm.
We'd like to take a look at it. Okay, I did see one other group just join. Before we get started on the actual presentation, Stefan, I know you
Hello,
just
sorry.
no problem. Do you have any? We're just doing updates right now. Do you have any updates to share with the group on your Gen 3 work?
No updates because we're putting Blood Pack on hold and thinking about a different comms to start up.
Okay. All right. Well, with that, I think we'll turn it over to the main agenda. Jawad, do you want to present and introduce the topic?
Yeah. So let me get the slides on the screen. Let me also just turn off my notifications. There we go. Okay. Is everyone able to see my slides?
Yes.
Cool. Yeah, so for the past couple of months, or maybe even a little longer, the Gen 3 platform engineering team has been kind of focused on seeing avenues of where we can reduce like operating costs of running one or more Gen 3 commons. And we've set an internal goal, although it might be a stretch goal, but to be able to set up a AWS account or environment, or I don't know what term to use here, with multiple Gen 3s running on it, that's still FedRAMP compliant, still has all the security and operational maturity as we have today. But if we can try to get that close to or under $1,000 a month. So that's sort of the overarching stretch goal that we've been working towards. So the way we've approach this problem is we just and I think that's the only way when we're dealing with delayed data coming back from making all those changes is we make changes, we analyze what effect those changes had, and then we basically keep iterating and make steady progress toward the basically the big end goal. We don't want to have anything negative basically from an operational standpoint, but we do want to see some good cost savings. So that's how we've kind of approached this problem. So the agenda that we're going to present today is we're going to talk about Karpenter and how we've been sort of tweaking it to give us some cost savings. So for those of you who don't know, Karpenter is a Kubernetes compute provisioning tool developed by AWS, and it's running in our clusters. And if you use our cluster level resources chart, then you've probably seen that as well. We've introduced a new layer as well called cilium. It's sort of a overlay network that runs inside Kubernetes and can detach your workloads from like getting real IPs and whatnot. And we'll talk about why and how we're gonna approaching Cilium. Um, and we've also been experimenting with some of our more expensive services, Data Portal being one of them, and we've made some good progress on that as well. Then I kind of want to just go over the AWS cost and usage reports for people to just quickly get an overview of how to use them, how to drill down into them with a quick example, basically. Um, so for Carpenter, I'm gonna give the mic over to Ajo, who's gonna talk about Carpenter.
Hi all, this is Ajo from Platform Engineering. So we are gonna talk about Carpenter and Spot instances. So cost was definitely a concern for us, especially compute in our Kubernetes clusters. So we were already using Carpenter for a while, so the basics were already in place. However, we felt further cost optimization was possible. So we started looking at how we could use Spot instances more effectively, along with some additional Carpenter tuning. But the real optimization came from how we tuned it and combined with Spot. Yeah, now the trade-off is Spot can get terminated anytime. So the question for us was, how do we take advantage of that cost benefit while still keeping the platform reliable? So I will walk through the approach we took and some of the key settings that we are using. Can we go to the next slide, please? So instance categories. So one of the things we did was avoid locking into specific instance types. We allowed Carpenter to choose from multiple instance families, so Carpenter can pick whatever is cheapest and available at the moment. It's like or we can think it of like flight booking. If you are flexible, you can get cheaper tickets. Or to the next slide. So next we enforce Spot usage explicitly using Carpenter constraints. This this basically says only use Spot nodes for those node pools, so that Carpenter won't spin up any on-demand instances, and this helps to reduce the cost a lot. Moving on to the next slide. So about we put some restrictions to instance sizing, like Carpenter might pick large instances which are expensive, or it could create very small instances which are not so efficient. So we defined a memory range roughly between 8 and 32 GBs to keep nodes in a sweet spot. And could we move to the next slide? Yeah, consolidation is probably one of the biggest cost saving features here. So like there are a few parameters like consolidation policy, consolidate after, and the disruption budget. So about this, when empty or underutilized, like Carpenter continuously looks for cluster and checks if it can run on lower or it can run on cheaper instances. So when a node is empty or underutilized, it will terminate it or even replace it with a cheaper instance. And also, we set this to run aggressively, say like after 1 minute. And also the disruption budget, it controls how many nodes can be replaced at one time. So we set it to 80, which means like if we have 10 or 8 out of 10 nodes can get replaced at a time. And these allows fast optimization. Yeah. Uh, Could we go to the next slide, please? Yeah, with all these settings in place, we are seeing spot interruptions, which means these spot instances can go down anytime, and we need to still balance with the we still need to have the uptime. So there are a few things we are doing to kind of have more uptime. Like for all the services, we have more than one replica. And also we have PDBs, that's the port disruption budget set. So there will be a minimum number of ports that are always available. And also critical workloads will run on demand, and less critical ones can go on a spot. Yeah, these are some of those settings that we did to uh, take control over the cost. That's what I have. Now I'm passing it to Ed for the cilium stuff. Thank you.
Oh, thanks, Sajo. Before you start in the cilium, maybe just stop for a second to see if there's any questions on the Karpenter presentation. Gordon, I see you have your hand up.
Yeah, I just would like to understand the migration path if we're not transition to using Karpenter. I mean, is there any gotchas or any redesign we may have to do?
Are you currently using cluster autoscaler?
Yes.
Um, yeah. Let me think. I think at first, like you just have to follow the deployment guide of Karpenter. I believe Karpenter is included in our cluster level resources chart, and you can just enable it. So the way Karpenter works compared to cluster autoscaler is cluster autoscaler, you just have set one autoscaling group, and it scales that one up or down, and the instance type is like only one instance type per autoscaling group that you can set. With Karpenter, though, everything is controlled with CRDs. So just like you would create a pod, you can create different sort of like all of these resources that are shown here are just these YAML files that you apply to Kubernetes. Um, and that's how you basically control or tell Karpenter what to spin up. It does not use an auto-scaling group, but it still needs the similar types of lookups. So like it needs to look up the security groups and the subnets to spin up in, and all of that. But I think that is based with labels. I believe you should be able to just deploy it from the cluster level or basically our Helm charts, and enable it. And that should set most of the things up. Ed, can you think of anything else?
I can't really think of much else. Yeah, as long as you set up Karpenter with cluster level resources and you have the necessary roles and um, AWS, which Terraform should provide, then yeah, it should just be pretty easy to set up through the cluster level resources.
Yeah, but you can also just follow their deployment documentation. The way it works, you deploy Karpenter and you just scale down the cluster autoscaler pods, and then Karpenter just takes over and starts replacing the existing nodes, basically, or at least adds new nodes.
Okay.
Yeah, I had another comment. If it wasn't clear, spot instances are basically excess compute that AWS has at all times, not being used by any other customers. So the price for spot instances can fluctuate a lot, sometimes give you cost savings of up to 90% for the on-demand price you would have to pay for that same node. So for us, it was very attractive to be able to use spot instances, but also, like Audrey mentioned, keep our uptime and keep everything running smoothly. And we're handling it by running everything in like a high availability distributed fashion with disruption budget to ensure that all the services are up all the time, even if a node goes down. So having that type of elasticity built into Gen 3 sort of allows us to use and take advantage of like things like spot instances to cut compute costs.
Thank
Any
you.
other questions or comments?
I guess you can move on to the next presentation then.
All right. Over to you, Ed. Cilium.
Hey everyone, my name's Ed Malinowski, and I'm going to be going over cilium. So, yeah, for cilium, let me start by talking about the problem. So, a while back, we did a lot of work on updating our deployments to use less requests so that we could pack our nodes as tightly as possible. For reference, we were maybe seeing like 30 to 40% node utilization based on requests before, and we really wanted to get that a lot higher. So after working to lower the requests for CPU and memory for all of our deployments, we saw that pod density was actually becoming a limiting factor for how many pods we could pack on a node. So for reference, each C2 instance only has a certain amount of ENIs that can really attach based on the instance type. And that correlates to only really having a certain amount of available IP addresses that you could have per instance type. We did some research and saw that flex instances were actually some of the best instance types you could use because they had almost effectively double the amount of IP addresses that you could set per node. Even with those flex instances, though, we saw that we still weren't hitting as many pods as we can per node because we were hitting the pod density limit with few exceptions. So with that, we had to figure out a new solution. Next page. The solution we came up with was to use virtual IPs instead of real IPs. And the solution for that we decided on with Cilium. So Cilium was just another third-party service that we could utilize in our cluster, and it allowed us to easily utilize virtual IPs instead of real ones, which let us set an arbitrarily large amount of IPs we could use per node. We settled on a max pod density of about 2,000 pods per node, which doesn't really matter because we'll never hit that amount, but it was just an arbitrarily large amount we set. After setting that, we noticed node utilization actually getting so high that our services started to become CPU starved to the point where some of them even started failing, which meant that we definitely hit the node utilization benchmark and needed to actually tune our CPU resource requests. Next page. So how to set up Cilium? It's going to be a fairly simple setup like most of the other changes here. Right now it's on a feature branch since we want to test it further before we let everyone else use it. But once it's merged, the only change you'll really need to do if you want to use it is to enable Cilium in the cluster level resources chart that we mentioned earlier. From there, you'll need to roll your pods so that get the new virtual IPs set. And optionally, you can even delete the AWS node and kube proxy daemon sets since Cilium can replace their functionality. There's likely going to be a short downtime during the switchover since traffic between the virtual IPs and the real IPs breaks. But once everything's rolled, we haven't really seen any issues in our cluster for using Cilium. Next page. So with including Cilium, it actually comes with a lot more features that we want to plan to use it for. So one of the features is Hubble, which is a UI that you can use to inspect network traffic. You just want more observability into your cluster. It also has the ability to set network policies, which can allow us to replace Calico and further trim down on some of our other daemon sets that we use. And it has the ability to do service-to-service TLS, which is something we hope to include in Gen 3 in the very near future. There's also a lot of other features Cilium has to offer, and if you'd like to see more, you can just check out their documentation. That's all I have on Cilium. Are there any questions before we move on to the next pulse coding optimization? All right. There's no questions. We go to the next page.
Right. I have one comment on Cilium is sometimes we've seen where like especially how we've designed our subnets in AWS and every pod needed to have a real IP. We've actually seen an issue where a subnet would run out of IPs and pod would struggle to come back up. Um, Karpenter is not able to work around it. They keep pointing fingers at upstream Kubernetes. And yeah, this effectively allows us to not run into that issue anymore. Since there aren't any like good um, upstream fixes for them, this basically just helps us manage that issue as well. So we can run practically virtual a unlimited scale of workloads if need be, which will be very, very handy once we start doing workflows at scale without having to set up additional networking in AWS because it all just happens within Kubernetes. So that will be interesting to see how Cilium helps us with that. Anyway, I'll move on to the next slide, which is shrinking portal.
Thanks, Jawad. So the next thing that we wanted to tackle was one of our largest or most resource intense deployments, which is Portal. So anyone who's worked with Portal knows kind of how resource hungry it is, but I'll just go into it very briefly. So Portal itself is actually a fairly lightweight application. All it really needs to do is serve some static website files. The problem is really due to the nature of how and what Portal needs to do. So Portal needs to be able to serve a very different set of files based on differing configuration files to even which Portal image you use. And that means we have to build Portal to be flexible enough to handle all these different configurations that are being set. Historically, that meant building Portal every time on startup, which caused Portal to take anywhere from 10 to 20 minutes to start and needing gigabytes of memory and a few CPUs to make sure it even starts up quick enough. One approach we tried to use a while ago to get around this was pre-building the Portal images through GitHub Actions and then using these pre-built images. But due to the amount of images that we had to produce for each of our sites and the complexity around the maintenance of all that, it didn't really take off. So we had to figure out a new solution. Next slide. So yeah, our new approach was to basically just cache the build artifacts in a persistent volume. So yeah, the way this new process works is to change the Portal deployment fundamentally. Instead of having Portal start by building a new set of artifacts every time on startup, it will instead just compute a checksum based on the current configuration. And based on that checksum, it'll check the persistent volume, which we're using S3 mount point for currently, for a matching set of artifacts. And if it finds it, then it'll just serve those artifacts instantly. This reduces the start time to typically under a minute for one. Yeah, if it doesn't find a matching set of files, it will create a job to build the new artifacts, which will then store in the persistent volume to start up quicker moving forward. This new job will have the typical requirements of Portal, which are a few gigabytes of memory and a few CPUs. But the original Portal pod will have just megabytes of memory and millicores of CPU, effectively making it so that we could reduce the startup time and the requests immensely. Next slide. So yeah, with that, I'll just briefly go into how to deploy it. The deployment for this is also fairly simple once it's merged. We have it on a feature branch well for right now because we're still trying to test everything through. We haven't noticed any issues, but yeah, once it's merged, all you have to really do is a few things. So for one, you'll need to create an IAM role with access to an S3 bucket. And we'll have to set it up so that a portal service account in the Kubernetes cluster can utilize that role through IRSA. Once you have that, you'll just need to update your values file for the Gen3 chart to enable this pre-built portal workflow, and then set the bucket name and the role name in the proper places. And yeah, as long as you have those set up, it should just utilize the new process and yeah, start up a lot quicker with a lot less resources. That's all I have for this. Are there any questions on this?
I had a question, Ed.
Yep.
Does this actually, it's the same question Stefan had. How does any of this change with the front end framework, whether it's as resource intensive, or yeah, any other things would be different if you use the front end framework?
So front-end framework is already a very lightweight application. This is more for the legacy installs that haven't swapped over to using front-end framework. If you're already using front-end framework, that's great. You shouldn't have this need for like a crazy amount of CPU and memory for any pod in the cluster. So nothing's going to change for front-end framework. But for everyone else, this is going to be pretty major.
Okay, that's another incentive that maybe not everybody was aware of, a benefit of using the front end framework.
Definitely.
Yeah, I recommend moving to front-end framework as well, but we've noticed ourselves it's not always as straightforward, and we still have some data portal deployments. Yeah, so this will at least give us a way to cut those costs for data portal, and I think our back of the napkin math is like more than 90% savings. And then once the initial build has happened, also let us leverage the ability to move pods around, because right now it can take up to like 10 minutes for a data portal pod to start because it rebuilds every time. Whereas this, it would just start within seconds because the builds are already cached, which is very much needed with our like new elastic architecture of moving things around as needed. Um,
I have a quick
just
question. Maybe you mentioned it, but I may have missed it. And how is the build working? Is when something change and the checksum finds the difference, is the build happening in the pod, or is it something that runs like on a cron job or on some sort of trigger before that?
Right.
uh,
So the way it works is it'll change the deployment to have a lot more init containers. So there's going to be an init container that will basically do a checksum of a lot of the configuration files that Portal uses, and then it'll checksum all those checksums together into like a final checksum. It will store that in a config map, and if it's different from that config map, then it will launch a job to basically build new artifacts. And from there, there's another in a container that just will untar those files. And yeah, as long as there's something in the S3 bucket, it'll just untar it
Yep,
instantly, and you'll have Portal starting up. Um,
that makes sense. Thanks. This is great.
yeah,
Yeah, I think it verifies all the configurations and also the code version. So if you're uploading or updating the portal version as well, that also kicks off the job to rebuild. Or if you're changing any configuration, it'll rebuild, but it'll only do it once instead of like every time it restarts now. So it'll be much better. I'm really excited to get this rolled out because me personally, I just hate seeing those giant portal pods. And we've not been able to do much with them for years, and this is going to be the best solution. Um, yeah. Any other questions or comments? Ooh.
The Gen3 front-end framework, I see there is no new releases since last year. Okay, the code is updated recently, yeah, but in the releases, it's keep at March 7th last year. So I'm curious about the latest release about the front-end framework. Yeah.
Yeah. I can check with Craig, but I think the way the front-end framework works is that you basically create your own little app and then you pull in the front-end framework, but I think you still would need release tags. I'm not sure. I know the code is being updated, but maybe we don't do like releases because it doesn't have a Docker file in itself, so it's not part of the regular release process. That's something that we can check up on, Michael, with I guess the Estet team and with Craig.
Okay,
Yeah, we
thank you.
can follow up on that. We talked about it in the roadmap meeting, but generally this year we have a goal to move all of our platforms to the front end framework. I don't know if that's gonna happen for every single one, but that's the goal. And add a lot more documentation. But we can, yeah, definitely talk to Craig and STED team about sort of the release process and what you should expect to see in terms of releases.
Yeah. Um, we also did something similar with front-end framework just recently. We just did it for K9 actually, where you like with Data Portal where you use a single base image that we release, but the look and feel and configuring of all the pages are just overridden using a config file, similar to Portal. And it's able to do that without running Webpack, which is kind of cool. I guess it's because it's like Next.js and very modern compared to Data Portal, which is like pure single page application or React. But yeah, now you should be able to soon or even now to run the front end framework with a pure configuration instead of having to fork, just like what you posted there, Sarah. Um, that'll also help us do better um, security updates of the base image instead of having to update every fork, which, yeah. Anyway, maybe that'll make it easier to adopt the front-end framework as well, since it'll be pure config if for the base app, unless you're doing custom stuff. Cool. Any other questions, comments? Alrighty, I'll move on. So something else that we're currently rethinking is the stateful services. So today and generally when following cloud native architecture, most of your databases should be in a managed service. It's just better architecturally and makes your life a lot easier. The caveat is that managed services are not cheap. They actually cost a lot of money. So we have been evaluating for some of our environments, for example, dev test staging or lower tier prod environments, whether it's actually worth paying for managed services or if we can look into alternatives. So for some of our comments, especially in earlier stages of the software development lifecycle where um, we can endure having maybe some downtime or if like data loss isn't the end of the world, you can do stateful services within Kubernetes. So if you've deployed our Helm charts, you've probably deployed Postgres in Kubernetes. So we've shipped our Helm charts with the Bitnami charts, very easy to spin up and super good for dev or testing. They're used in all of our CI pipelines, for example. But there is just a single pod, which is the single point of failure. And right now, the Bitnami charts are kind of out of support. So something that we're evaluating is cloud native PG. And for some of our comments, I mentioned like Elasticsearch as well. We are able to, and I believe that we do that in CI as well. Basically, just run Elasticsearch on Kubernetes. That helps us cut the cost of RDS or the managed Elasticsearch service, which can, sometimes be quite expensive depending on the scale. Aurora is very helpful because it helps us scale down when services are not in use. So that was kind of nice compared to old RDS, but still, I feel like there is a way. So, but with Cloud Native PG, we can run a high available with backups and point in time recovery Postgres clusters in Kubernetes. So, um, we haven't merged or set up anything in Helm yet, but there is something that we're planning on integrating. So for comments where you would like to take on running Postgres yourselves, if you feel like you have the skill set, you can save a lot of money in AWS, basically, doing it this way. Um, I've personally used Cloud Native PG a lot for some stuff that I use for personal applications, and it's pretty cool and has a lot of configuration options that makes it a valid RDS replacement candidate. Or if you're running in a non-AWS environment, for example, on-premise, you would get the similar kinds of benefits as AWS RDS without having to go to the cloud. So this is kind of cool and something that I want us to build more support for in Gen 3 going forward. Okay, any questions, comments about the stateful services? I guess that was, yeah. Okay. I will just move on to just a quick way of what we're using the AWS cost and usage reports for. This might be super basic for some people, but I thought it was good to include in this because this is a huge part of the whole cost optimization exercise. So once we're making these changes, how are we making sure that these have good impacts and how are we finding things? And a lot of the times while we're like looking at our AWS costs, we find some stale resources or something. So it's always important to practice good cloud hygiene. So if you open a AWS cost and usage report, you've probably just seen these like bar charts. Don't really tell you much apart from how much you're paying AWS, which is, I guess, nice. But if you want to figure out what is accruing these different costs in your AWS accounts, something that's really nice to use is these filters and groups on the side. So just a simple thing where you could, for example, group these bar charts into the service here, and it will show you exactly like, oh, so breaking down the cost into different categories. So we can see that EC2 instances in this particular account used to be higher, and we saw like maybe a decrease here from January to February. You can also see some other services like OpenSearch is going to be this chunk every time. The EC2 other, and basically you can drill down further as well. So if I want to figure out like what's actually like which instance is it that is driving these costs, you're able to do that. So in the filters, you can choose like what services to include. So we can exclude everything else apart from the EC2 instances and group by the instance type for example. And doing that, it shows you, oh, okay, so there are instances with R8i flex 8x large, which tracks because we did spin up a big instance to support something else. So right now, this top thing is our Kubernetes cost, whereas the other instance that we spun up to do other stuff is taking up like 90% of the cost. But this is like super clear, and we can find the instance as well. You can filter on, for example, resource here. It'll show you the exact instance that is accruing this cost. You can do this for every service that AWS has. You can also group by usage type. Then it'll show you like exactly what AWS is charging you for, demystifying um, this into some usable data that gives us targets to try to see if we can cut some costs in those avenues. So we're well on our way to be able to get to, the sub $1,000 multiple commons AWS environment. Not quite there yet, but hoping to be there soon. And yeah, if you want to follow along, so to a lot of the stuff that we're deploying to Kubernetes, I mentioned the cluster level resources chart. It is in the Gen3 Helm repo. Cilium will be part of this. Karpenter is already a lot of our like same resources that we deploy to all of our AWS clusters or others are also included here. Yeah. And something else that we're looking into to further cut costs or increase the efficiency of running Gen3 in AWS. We are going to do the EKS 135 update or upgrade soon. With that, that opens up some doors to use Graviton instances, which are cheaper ARM-based instances, but has good performance. That'll further give us hopefully some more cost savings. And we are evaluating the use of VPC endpoints everywhere. Maybe not all of our environments need them. Are we able to drop them? That'll also start shaving off some cost. And yeah, so all of these updates will also be made to our Terraform, built into the CSOC portal, and basically our cluster level resources chart in Gen3 Helm. Yeah, I think that was what we had to present. So if anyone has any questions or comments, please feel free.
Especially if anybody has any, cost saving ideas that you yourself have implemented, but that are sort of a different flavor than what you saw here, would be interesting to hear.
Yeah, that'd be really cool.
I know the CTDS platform engineering team is not the only team that's ever considered AWS costs.
Yeah.
I think we're gonna try to somehow reduce costs. So especially in our lower environments. So I think Carpenter looks like a very good option for us. So we're just gonna experiment a little bit and see how much we can save. So we're
Yeah.
definitely gonna try that. Yeah.
Internally, we're also trying to use Karpenter more to be able to differentiate costs, especially for our upcoming workflows integration. So we will be able to spin up different node groups with different tags in AWS per user. We did that before for another workflow execution thing with genome-wide association studies. There we were able to spin up different node groups in Karpenter per workflow because those were more long running. But cost tracking and cost separation and stuff can also be done since basically these are just Kubernetes resources. They can be created programmatically, basically per user. So highly recommend Karpenter. Yeah.
Does Karpenter support tagging on the EC2 instances?
Um,
Can you
Tiling? Sorry.
tag
Oh yeah.
tag
Yep.
tags?
So you can have different sort of node pools, I think they're called in Karpenter, which can have different tags. So for example, our workspaces has different tags, regular nodes has different tags, so that in the cost and usage explorer, you can just separate by tag and figure out, oh, so workspaces cost that much. Or workflows for that matter, especially once we start integrating more um, AI stuff into our commons, that'll be more important. So it doesn't just include the EC2 costs, but also the data transfer costs are included that way as well. So how much data transfer did this tag accrue, or how much data like EBS volumes and everything attached to those nodes. It gives us that capability out of the box, which is kind of nice.
Thanks.
Any other thoughts or questions from anyone? Okay, well, the other thing to briefly touch on is if there's any ideas for next month's CSOC working group meeting. I think Jawad, you had some idea of we could have a hands-on or training session or to bootstrap the CSOC dashboard. Is that
Yeah,
accurate?
I think that could be helpful or cool. Where we start from scratch and then we basically bootstrap the CSOC cluster or the CSOC portal itself, and then we deploy an environment through it together. Um, I'll see if I can get an AWS account for that, and then yeah, I think that could be cool. We
Carmen,
will.
were you gonna try to make progress on this before next month?
If you do, please let me know.
Yeah.
Yeah.
Okay. Let me try.
Some other topics, maybe I can show like my development workflow. Like how do I start develop or like set up the development environment and develop the CSOC portal. Um, yeah. And maybe I've explained it before, but it'll maybe be a little easier to see the architecture, the different small pieces and how they're all interacting together. Um, could be fun to actually do a feature development as well together. Something stupid simple, but that would be quick, maybe. Yeah.
I have a question. For
Yeah.
those two that you just gave examples of, Jawad, would it make sense to do like in terms of what am I trying to say? Would one come before the other? Like maybe it would you, chronologically, if you were doing both of those things, would one come before the other?
Um, Chronologically, probably, yeah, you probably have to develop before you deploy. But since we've already developed things, like it is ready to deploy.
Mm.
Yeah. But yeah, yeah, both are interesting topics. They don't necessarily need to happen one before another. But yeah, the deployment or the bootstrapping now that's a loaded term though. The bootstrapping of of the portal itself with Keycloak and everything. I think it's an interesting topic because like most or some of it is automated, but there's still like some manual pieces that we like tried to document, but it's um, and understand the different pieces more. And maybe that sparks ideas on where to improve things in the future. Yeah. But yeah, they don't need to happen in any particular order, but maybe naturally if people want to see one before the other. I'm flexible.
I mean, well, I was gonna think the deployment. I mean, this is really the CSOC working group, I guess, is one of its major kind of goals is to help collaboratively develop this platform and to get folks like to be using it is a good step in that direction, I guess, to get feedback on it.
Hmm. Yeah. I mean, a technical deep dive session next time and the next time after, and then we can like figure out the exact topics, I think would be really cool. And I get to show the internals a little bit more, so that's kind of fun. Because there are some really cool technical pieces in that portal. Yeah.
But if
I
you're
haven't
not,
had a chance to try it out. I think once I try it out, I'll be able to give some feedback.
Yeah, that'd be
Yeah.
cool. And maybe like if we do it in a session together, like um people can try to follow along or at least to the video afterwards, and try to kind of deploy it themselves. In your case,
Yeah.
Gordon, you guys already have clusters and everything deployed, so the deployment is super simple. Um, it's basically just yet another microservice that you deploy. And then if you have the network connectivity between those clusters, which I think you already do, you
Yeah.
can somewhere in the middle and then just onboard them, which would at least give you the management of Gen3. And then we can also talk about like how to bootstrap and sorry, deploy a new Gen3 environment. Yeah.
Yeah.
Cool.
Sounds good. Yeah.
all right. I know we're just about out of time. Anything else anybody wanted to bring up today? Okay, well, thanks so much to the CTDS platform engineering team for the presentations today. And I'll reach out at some point over the next few weeks about the agenda or topics for next month. Thanks, everyone.
Thank you.
Thank you, everyone.
Thank you.